All right, we've got our AP Calculus BC free response questions, the release ones from 2024. Let's take a look at the first question here. First two questions, of course, calculator active, including this one. Number one, the temperature of coffee in a cup at time t minutes is modeled by decreasing differentiable function C, where C of t is measured in degrees Celsius and gives us closed interval from 0 to 12. Selected values of C of t are given in the table shown. So a couple things about this that you might note. Anytime that they say differentiable, that is, well, I'm going to make a connection to differentiable, meaning that it's got to be continuous also. A lot of the theorems that we talk about, we use in calculus requires either a continuity or a differentiability. So making that connection could be helpful. And then sometimes this decreasing thing could come into play as well, especially if we're talking about an estimate of some kind, especially a Riemann sum, which I do believe this one has. Oh, look at that. Answer choice B. Okay. So let's look at A. Approximate C prime of 5 using the average rate of change of C over the interval from 3 to 7 and show the work that leads to your answer and include units of measure. Okay, so at no point should you ever, even though you have access to a graphing calculator, plot this thing as a scatter plot and try to come up with a function for C. No, just don't do it. This one is telling us very specifically what to do, and it even tells us the interval to do it over. So this is pretty much how we started the year in calculus. The C prime of 5, this is an instantaneous rate of change. Instantaneous rate of change, which is the tangent line, of course. And the average rate of change, which this question is asking us for, is the same thing as slope. The average rate of change is slope of a secant line. And we often use the slope of a secant line in order to approximate the slope of a tangent line, especially when we don't have an explicit equation to work with where we can take the derivative. So we just have a table of values and we can pick some close values to, in this case, 5. They even tell us which ones to use. The closest values here are from 3 to 7. So I'm just going to find the slope between those two. That's it. So I would write something along the lines of, change your color to blue, C prime of 5 is approximately equal to, because this is the slope of the secant line, which is approximately equal to the slope of the tangent line. And I would want to set this up as a slope, so it's a difference quotient. And I got to do the change in y over change in x. Don't get it upside down. So I'm going to do C of 7 minus C of 3. All of this over 7 minus 3. Now, do you have to put the C of 7 and the C? That isn't even a C of 3. What is that going? What's going on there? No, it is. Do you have to put the function like this, like the C of 7? No, you don't. You can just evaluate it. The C of 7 is 69 minus this 85, the C of 3, and then this is over 4. Now, as far as this goes, if you left it like this, though, you couldn't get a point for your actual answer, and the reason why is because you got to actually pull some values from the table in order to get that. And at this point, just throw this in the calculator. If it was calculator inactive, you're more than welcome to leave it just like that. So let's do this little guy, and I'll throw in a quotient thingy, and 69 minus 85, and then divide that thing by, if you're not feeling confident about it, 7 minus the 3. Okay, we got an answer of negative 4 equals negative 4, and then I'm done, right? Except I'm not, because it says include units of measure. You can guarantee if they say that, it's worth a point. So let's see what our units are supposed to be. So on top here, when we were calculating our slope, this was our y values, our C of t values, which is in degrees Celsius. Do that in red. so degrees Celsius. And then on the bottom, we're dividing it by the 7 and the 3, which of course are our x values, our t values here. So that's in minutes. So I know that this should be in degrees Celsius per minute. And that should do it. Now, what I'm going to do here is I'm going to, just based on experience of taking these free response questions, think about like, where do I think these points are going to go? Like, how many points do I think I'm going to get? And how are they going to divvy up those points? Remember, they're 9 points each. So I would say that the -4 as the estimate of the slope, that is probably our first point. So that +1 for the slope, the average rate of change. And then since it asked for the units, I would probably guess, why did I scribble them out? Because I thought I was on the highlighter. I would probably guess that that units was the other point. And I would also guess, since they say show the work that leads to your answer, that if you just had -4 degrees Celsius per minute, that they actually would not give you this point. If they ask for it and you don't show it and you just put a number, and this goes for any of these kind of questions that are calculator active, make sure you get the calculus on your paper even though you're using the calculator to evaluate it for you. If you don't, you're going to lose some points. Okay. Part B, use a left Riemann sum with 3 subintervals indicated by data in the table to approximate the value of the definite integral from 0 to 12 c of t dt. Remember, definite integral, we're talking about finding the area underneath our curve. And since we don't have an actual explicit function for c of t, we're using a Riemann sum, so a whole bunch of rectangles, in order to approximate it. And it tells us not just a whole bunch, but 3. Last part of this, interpret the meaning of 1 over 12, definite integral from 0 to 12, c of t dt. And you can see this 1 over 12 right there, a little bit different from what we are evaluating. And this is usually associated with, whenever you have this number right up front, an average value. And I know that because look at the numbers of the bounds of integration. The lower limit is 0 and the upper limit is 12. If I subtract those, I get 12. All right, so that should clue me into the interpretation of what that thing is whenever I get to it. Now, if you find it handy, you can do a small little scatter plot of these values, and that can help you gauge which one of these you're supposed to use. A left Riemann sum, however, if you don't need the picture of the graph, we know that it would include the first left endpoint, but it would exclude the last right endpoint. And we'll see that in our little scatter plot here. And the scatter plot doesn't have to be perfect. It's just something quick and easy for you to visualize what your data is looking like. So our first point here is at 100 at 0, so we'll say that's 100. And then at 3, we're going down to 85, 7, 69, and then a 12, wasn't it? 55. And you can visualize from your data that, of course, your function, if you can imagine a function here, it would be decreasing. All right, and then we wanted to approximate the area underneath the curve here with a left Riemann sum. Riemann sum is the sum of products. Essentially, it makes rectangles here. And since I'm using a left Riemann sum, I'm going to use the left endpoints as my heights of my rectangles. So my first one is going to use the height of 100, the next one 85, and the last one the 69. And so just like I said before, if you didn't need the scatter plot, you would know that you would use the left endpoint, the first left endpoint, but you would exclude the 55, which is the last right endpoint. Okay, so this should help us. As a matter of fact, I'm going to swipe this guy and just bring it down here. I'm sure you can do the same thing on your actual AP exam. So I'm going to write that the integral, definite integral from 0 to 12, c of t, and we're approximating here again, so I'm going to use the approximately equal to symbols, and I'm going to set it up as I can see that there's a product of two things. Riemann sum is supposed to be a product of function heights and widths of intervals. So I'm going to actually set it up like that. So I have the C of 0, that's a C by the way, times the width, and our width, I can see pretty clearly here, is 3. So times 3, plus my next one is going to be C of 3, which is going to be the 85, and it's multiplied by, now a super common mistake is after you get that first width is just assuming that all of them are 3, but they're not. You can see this one is 7 minus 3. This one's 4. So times the width of 4 plus, and then our last left endpoint here is C of 7, which is the 69. C of 7, and its width, is it a 3? Is it a 4? No, this one's a 5, so 12 minus 7 gives us a 5. Now, would this earn us a point? I don't think so. I think we have to pull the numbers in from the table or from our little scatter plot here, where he said this is 100 times 3, plus C of 3 is 85 times 4, and we had the 69 times 5. Once again, did I have to have the actual function values? I don't think so. You can just pull those numbers in as long as it's clear that you have a function value pulled from the table and the width of each of those intervals. And I would probably warrant that that's a worth of points, just the setup for that thing, and then, throwing it into the calculator so you can get your estimate for the area. Come on, Desmos, cooperate. There you go. All right, so this next line here, we've got 100 times 3 plus 85 times 4 plus, and then 69 times 5. So we have 985. Right with a pen. There you go. 985. Now, it doesn't ask you for units, and the units would be kind of bizarre on this anyway, in case you were wondering. Since the C of T has units degrees Celsius, and then the dt has degrees minutes, you actually have degrees Celsius times minutes, which I don't know what that is. But it doesn't ask that. It does ask instead what the heck this means. 1 over 12 times the definite integral that we just got, 0 to 12, C of t, what is going on here? C of t dt. And as I was talking about, the fact that we have this fraction out front, especially combined up with our limits of integration being 0 and 12, this implies that we're taking the average value of something. So remember, average value looks like this: 1 over b minus a, definite integral from a to b of whatever your function is. And this gives us the average value of f of x on the interval from a to b. So remember, what we were doing here is that we were accumulating temperature, as we can see right here, and then we're going to divide that accumulated temperature by 12, which is the length of the interval, 12 minutes here. So if I divide, where were we going? Remember what we're saying right here, that this is in degrees Celsius per minute? And if we divide that by the minutes that are out here with the 12, these minutes and these minutes would cancel each other out, just giving us degrees Celsius, which is the average temperature of the coffee over that time interval. So I would say that this represents the average temperature of the coffee. It's in a cup, isn't it? In the cup. And I don't think that's enough. I think that you do need to include the time interval. So it represents the average temperature of the coffee in the cup in degrees Celsius from t equals 0 minutes to t is equal to 12 minutes. Okay, so what do I think the points are for this one? I'm going to say that the first point is going to come from the setup of the Riemann sum. I've seen enough of these to know that if they ask you for a particular sum, just having this setup is worth a point. And then when we look at the scoring guideline for this, usually you don't even have to have the whole thing right. They say if there's like 6 or 7 terms in it, you just have to have a fraction of those things, but it's most of them. Riemann sum, and then I would say the next point here would be your actual answer. So +1 for the answer. And then I would say also a +1 for this interpretation because they did ask for it. So what are we up to? We're up to 5. Get 4 more points here, divvy up for the rest of it. Let's take a look at C. All right, so we got a time interval from 12 to 20. Notice, of course, that's beyond our table here because we only have 12. The rate of change of the temperature of the coffee is modeled by this exponentially whatever equation, where C prime of t is measured in degrees Celsius per minute. Find the temperature of the coffee at time t equals 20. Ooh, show the setup for your calculations. Of course, they want you to show your work. What math teacher wouldn't want that? Okay, so if we want the temperature of the coffee at t equals 20, this means that we're looking for C of 20. I'm not looking for C prime of 20, I'm looking for C of 20. If I have C prime, what do I have to do to C prime in order to get C? I need to take the integral of it. I need to anti-differentiate it. So if I take the integral of C prime of t with respect to t, I should be able to get C of t with some constant integration, which I don't have to worry about because I have some limits of integration here. Specifically, this is going to be a definite integral from 12 to 20. So I'll put a 12 down here, 20 up here, which means that this would be evaluated from 12 to 20, which is equal to C of 20 minus C of 12. Now, we're looking for this thing, of course, but you might be scratching your head, well, how the heck am I supposed to get C of 12 based on this? From the table. So going back up to the table, remember that C of 12 is equal to 55. So if I put a little 55 right up in there, and I add that to the other side of the equation, I will essentially have myself an equation that I can throw into the calculator to find the temperature of the coffee at t equals 20 minutes. So C of 20 should be equal to 55 plus definite integral from 12 to 20, C prime of t dt. So you can go straight to this answer, and this looks sort of like those kind of velocity position kind of equations where this is your initial position and this is your change in position. It's just like that, except for with coffee and temperature, your initial, and when I say initial, I mean at 12, your initial temperature, and then here's your accumulated change in temperature in order to get the temperature at 20. So it's straight up time for the calculator, of course. Oh, I do need to plug in that equation, don't I? And when you plug this thing in, of course, use just the x's, not the t's, and don't put in a c prime, of course. So whatever it is that you want to call your equation, it could be y, it could be f of x. I tend to use f of x, but we'll use c because it is coffee. So I'll use a c of x is equal to, and then start off a little fraction deal, and I need a negative 24.55, and then e to the, and the exponent here is 0.01 x over x. All right, it's this lovely hyperbola looking thing. Okay, and then what we want to do is set up our integral equation here, which was 55 plus the definite integral. And I get that under my little functions. Of course, if you have your little keypad, you can type in int in order to get it. Oop, there we go. Going from 12 up to 20. Inside here, this is the benefit of calling our equation on box number 3, c of x, because then I can use that inside of my integral here. So c of x, throw in a dx, or else it won't do anything. It's even warning you. So a dx, there we go. And so we're saying that this thing is equal to 40, and remember, all these decimal places, I don't need them, but I do need 3. So 329 degrees Celsius, I do believe. Okay, so I think that should do it. And let's see, does it say us to interpret? No, I don't think so. So what do I think point breakdown is going to look like here? Well, all right, so we do have an integral equation. So with the integral equation, usually it is a setup of, hey, do you have an integral in here? Do you have the right integrand, which is, in this case, of course, the c prime? I do believe that that's a point. Of course, it makes sense that your answer is worth a point. And it's possible that there's another point here, and that is, you remember where we struggled for a second in thinking of what this initial condition was, the C of 12, I believe that using that is the final point. If there is an extra point, we'll look at the scoring guideline at the end and see. So +1. All right. So that brings us up to 8, right? Oh, that means that this last one, forget about it. It's only worth a point. Just move on. No, I'm kidding. Let's get our point. For the model defined in part C, it can be shown that, oh, it gives us the second derivative. We don't even have to get it. For the interval from 12 to 20, determine whether the temperature of the coffee is changing at a decreasing or an increasing rate, and give a reason for your answer. All right, so anytime we're talking about increasing or decreasing, this means that we're looking at a derivative. So we look at derivative. Question mark? Okay, but we want to know, determine whether the temperature of the coffee is changing at an increasing or decreasing rate. So isn't that like talking about C prime? So I want to look at C prime of t. So this is the rate of change in the coffee. And we want to know, is this thing increasing or is this thing decreasing? Increasing? Well, what does that mean if it's increasing? That means that it has positive slope. And if it has positive slope, that means that C double prime, that's its derivative, which measures C prime slope, that would be greater than 0. And then as far as the decreasing part goes, then that means that if I take the second derivative of this, measuring the slope of C prime, then that would be less than 0. That's essentially what we need to find, and that's why they gave us the equation of this second derivative here, because we're going to use that to gauge whether or not C prime is actually increasing or decreasing. All right, and let's see. I guess you could graph this. I think it's kind of a waste of time, and the reason why is because now I'm just going to break this up into parts. Like, for example, this is exponential right here, and exponentials are always positive, so this is plus. Boop, boop. And then look down at the bottom. Down at the bottom, we got a t squared. Pretty sure, since we're not dealing with any imaginary numbers, that's also positive. So the whole entire sign, whether the second derivative is positive or negative, is highly dependent upon, solely dependent upon 100 minus t. Okay, now remember that they gave us this interval from 12 to 20. So the biggest number that we could possibly put in here is something that's a little bit less than 20. We're subtracting that away from 100, which means that that is also positive. Looks like everything is positive. Since everything is positive, this means that the rate of change in the coffee must be increasing at, or changing, I should say, at an increasing rate. So here, let's just write up our final conclusion and go back to decimals for a second. I don't know. And be done with this. And by done with this, that means we're going to look at the scoring guideline for some more details and stuff. All right, so I'm going to say the temperature of the coffee is changing at an increasing rate. That's not good enough because it says give a reason, so we have to give a because or a since. Since C double prime of T is positive, and I'm going to cover my base positive. And cover all my bases by saying where it's positive. I don't ever want to say something at a single point or whatever. I want to say that it's over this interval here. It's positive for, what is that, 12 is less than T, which is less than 20. Temperature of the coffee is changing at an increasing rate since C double prime of T is positive for that interval. Okay, and then I think this is our last point here, so +1. Okay, so we're going to take a look at the scoring guideline, see how we did, and then see if the points that I thought they were actually were the points. Okay, so the scoring guideline is just like right down below here. So we had a -4 degrees Celsius per minute, and that is the answer that we got. And we can see the point breakdown. There's two of them. We have the estimate with supporting work was a point, so actually having the difference quotient of the slope calculation there, and then having the units was a point. I do believe that's the two things that I said up here, wasn't it? Yes, so here's the -4 for a point, and then the units. Degrees Celsius per minute, did they tell us that? Degrees Celsius per minute. All right, let's look at their scoring notes because sometimes they reveal some important information here. So on the first one, I think this one's probably highlightable. To earn the first point, a response must include a difference quotient or a difference and a quotient as the supporting work. In other words, if you just had that -4, like I said, no first point. And let's see, another thing that I would say, oh, maybe this one, a response that represents only units without a numerical approximation and does not earn the second point. Okay, all right. Let's look at part B. So that was the first 2 points. And then on part B, it looks like we have 3 points. Form of the left Riemann sum. And this is a kind of common language on the free response questions, that it might be a two-part kind of thing. They're looking for the form. It might be the form of the quotient rule or something like that. And then your final answer is the second point. And that's what happened here. We had the form of the left Riemann sum, which was worth a point. Our estimate was worth a point. And finally, our interpretation. So let's look. So we had our 985, which is the number that I think I remember us getting. Yep. And then you have to have a form of a left Riemann sum. And notice what they did is they actually subtracted for their intervals here. You don't necessarily have to have that, but we do need to have a width times a function value, width times a function, width times a function. And then our interpretation is the average temperature of the coffee in degrees Celsius over that time interval. All right, let's look at some of these scoring notes and see what might be important. And this is something I was alluding to first. To get that first point, at least 5 of the 6 factors in the Riemann sum have to be correct. So let's see, 1, 2, 3, 4, 5, 6. So if you If you thought that all of the wits were 3, well, then that wouldn't be of the 6, 5 of them, and you would miss it. If you just thought this was a 4, this was a 4, got all the other numbers right, then you would still get this piece right, even though your estimate was incorrect and you wouldn't get the estimate point. Okay, response that, notice that it has the C of 0, C of 3. It gets the first point, the form of the Riemann sum, but the values have to be pulled from the table to actually get your estimate point. All right, let's see what else might be important. Oh, this is interesting. A completely correct right Riemann sum earns the first of the 2 points. But an unsupported, I guess 806 must be a right Riemann sum, does not get either of the first 2 points. So if you mistakenly did a right Riemann sum, you can at least, they'll give you something. They'll throw a bone your way and say, well, you know what a Riemann sum is, even though you used the wrong one. So I'll give you one of those points. Units do not affect this, and to earn the third point, the interpretation must include both average temperature and the time interval. Okay, that is a kind of important. Response does not need to reference units. However, if incorrect units are given in the interpretation, you don't get that third point. All right, and let's move on to C, scoring-wise. C was worth 3 points. Our integral here, that looks familiar, using the initial condition. This sounds like differential equation kind of language, and then having our answer. So 3 points. Did I say 3 points? 1, 2, I did, yes. And look, integrals right here, and then our initial value, and then did we get this right? It was 40.329 degrees Celsius. 40 points, where, am I in the wrong one? Yep, 40.329, yes. Okay, there we go. All right, so all of that looks good. And let's look at some of the key features of the scoring guidelines. First point is earned for a definite integral with an integran. If the limits of integration are incorrect, the response does not get the third point. So, for example, you can get the point for the integral if you had the wrong limits of integration here. And using your initial condition, you could still get that point, but the answer has to be accurate. Let's see. This is actually something that they're really starting to press a little bit more firmly on, and that's your differential, your dt. They won't take off points if it's still clear what is in the integrand and what's not. So for example, it says unambiguous. So this is clear. This is still understandable when you have your initial condition plus your integral, and notice that there's nothing on the outside of it. So this one, even though you don't put your dt like it's supposed to have, it's still obvious that there's nothing after it, so this must close off the integral. It's bad form, however, it's clear enough for them to see what you meant. However, the ambiguous, means that it's not clear, happens when, you threw the initial condition, and though you thought that this meant that, hey, this thing closed off after this, well, we cannot imply that, especially since there's no dt that was written, and so it looks like, is the C of 12 in the integral? Or is it on the outside of it? I don't know. Well, I'm not going to give you that point, right? Okay, and let's see. The second point is earned for adding C of 12 or 55 to a definite integral with a lower limit of 12. So they're making a connection between having this 12 here, and the 55, because that's where it came from. Third point is earned for no additional simplification. Answer of just, this is absolutely important, especially in a calculator active question. Answer of just 40.329 with no supporting work. Nope. No points. 0 points, even though it's the correct answer, because you didn't show up your work. All right, and then finally, that does leave us with 1 point, answer with reason. And let's take a look at what their actual answer is, because C double prime of T is greater than 0 on this interval. The rate of change in the temperature of the coffee, C prime of T, is increasing in this interval. And that's more or less what we said. That is, on the interval, the temperature of the coffee is changing at an increasing rate. We did have to give that reason. And let's look at what their scoring notes include. This point is earned only for a correct answer with correct reason that references the sign of the second derivative. A response that provides a reason based on the evaluation of, I think this is important, evaluation of C double prime at a single point does not earn this point. It has to be over an interval that this whole thing is decreasing or whatever. A response that uses ambiguous pronouns such as it is positive, so increasing doesn't get that point. So avoid your pronoun usage here. And a response does not have to reference this interval to end the point. This is weird. So I think that is a little bit unclear, honestly, especially since you're saying that the derivative is greater than 0. Where is it greater than 0? And they just said right up here in this other bullet that you can't do this at a single point. I guess the interpretation is if you left this part off and you just said that C double prime is greater than 0, you're saying that it's always greater than 0. I don't think that's necessarily true because that's not true beyond 100, but whatever. We'll just go with their scoring guideline. All right, so that should conclude that first free response question on our BC Calculus exam from 2024.